Okay, now we want to find the polynomial with given zeros. Well, that's easy. You probably know how to do that already. But for example, let's find a polynomial with zeros at x equals -5, 1, and 3. Okay, well, writing out more detail than necessary, and making sure that we understand as completely as possible. X plus 5 is 0 when x equals -5. X minus 1 is 0 when x equals 1. X minus 3 is 0 when x equals 3. So, x minus 5 times x minus 1 times x minus 3 is 0 when x equals -5, 1, or 3. And then clearly, if we substitute -5, we've got 0 times, well, that would be what, -6 times -8. 0 times 48 is 0. If x equals 1, then you have 6 times 2, 12, times 0, which is 0. If x equals 3, you have 8 times 2, which is 16, times 0, which is 0. In every case, you get 0. And you can easily draw a graph. I'll just kind of toss that down here. You got -5, you got 1, and you got 3. And you have a y-axis. We know what the end behavior is, so we can detail that. So you get a curve that looks very much like this. Okay? Now, just a little harder. A little harder, but just a little. Finding a polynomial with given zeros and a given y-intercept. Okay? Well, so we want to have a y-intercept of 0, 40. Okay? Now this is very simple. Once we have these 3 zeros, we've got our polynomial x plus 5 times x minus 1 times x minus 3. That's going to have zeros at these 3 points. But it probably doesn't have y-intercept at 0, 40. Let's check it out. Well, the y-intercept, if x equals 0, we have 5 times -1 times -3. That's 15. So here's our y-intercept, 0, 15. We want a y-intercept of 0, 40, but we don't want to change the zeros. Well, all we have to do is vertically stretch this thing by a factor that takes the 15 up to 40. Okay? So, solution, x plus 5 times x minus 1 times x minus 3 has the required zeros and y-intercept of 0, 15. If we vertically stretch this, this polynomial by factor 40 over 15, which of course reduces down to 8/3, which is about 2.7. 2.6 repeating, but okay, approximately 2.7. Well, we take this up, stretch it by factor 2, we get up to 0.30. Stretch it by factor 3, we get up to 0.45. We don't need to go that far. We need factor approximately 2.7, exactly 8/3. Okay? Results in the polynomial p of x equals, well, you have your x plus 5 times x minus 1 times x minus 3, and you multiply this by, well, 40 over 15. I'll do that, 40 over 15, just to get to the original numbers, equals 8/5, 8/3 of x plus 5 times x minus 1 times x minus 3. Okay? And now if you plug in 0 for x, you get 5 times -1 times -3, which is 15, multiplied by 8/3, which does give you 40. Okay? 1/3 of 15 is 5, and 8 of those is 40. And that then gives you a polynomial with a y-intercept up about here, but with the same zeros, since I'll go through the same zeros. It's going to be vertically stretched down here pretty quickly. Up here. Not a great picture, but you get the idea. If you understand vertical stretches, which we've been struggling with since January, okay, make sure you review that and understand it. And then just a bit harder, finding a polynomial with given zeros through a given point. Okay? Well, okay, have zeros at x equals -5, 1, or 3. Passing through the point. Now let's just see. Let's say I estimate, that you don't need to do this, which is kind of fun. Okay, estimate this point. Well, this looks like it's about -2, and that should be about 25. Okay. Now, I don't think this polynomial really goes through -2, 25. It's highly unlikely. But let's find the polynomial whose equation does go through -2, 25 and see what we get. Well, if x plus 5 times x minus 1 times x, and it's minus 3, doesn't pass through -2, 25. It isn't 0 at x equals -2. Which it ain't. Then the right vertical stretch you get it there. Okay? So let's let A times x plus 5 times x minus 1 times x minus 3 yeah, kind of a little bit like this. Have value 25 when x equals -2. Then A times -2 plus 5 times -2 minus 1 times -2 minus 3 has to equal 25. Well, there's only one variable to solve for. The rest are just numbers. Very easy. We get A times. I'm not going to write out all the arithmetic. I'm probably going to do it wrong, but I'm not going to write it out. Okay, that's 3. That's -3. And that's -5. 3 times -3 times -5 is 45. So A times 45 should equal 25. So A is 25 over 45, which is 5/9. So P of x equals 5/9 times x plus 5 times x minus 1 times x minus 3 passes through -2, 25, the zeros, and x equals -5, 1, and 3. You can see clearly that -5 is going to make the whole thing 0, 1 is going to make the whole thing 0, and 3 is going to make the whole thing 0. And if you multiply it by 5/9 and plug in -2, you get 5/9 of 3 times -3 times -5. 5/9 of 45. 1/9 of 45 is 5, and 5/9 of 43 is 5 times that, which is 25. So there we have it.